Hey there, folks. So this is chapter 13, and it is October 19th. Should be a Monday. And so today we're looking at energy. We've shifted from uh, whatever it was we were doing before. We've changed courses a little bit here. But yeah, now we're looking at energy. And so we're looking at resources, actually. This whole section will be about resources, and we'll talk a little bit more about what that is altogether. But right now we're going to look at energy. But when we talk about resources, I want you to think, and you can kind of look around your apartment or look around your house and just look at all the different things in your house and think about where the raw materials came from to make that table, or where the raw materials came from to make that wall, or to make the floor, to make the glasses, or whatever. And what you'll find out is it all came from the earth. So it's kind of amazing that we live in a world where we have refined resources, but we don't really think too much about where they come from. So that's what this whole section is going to be about. And we're going to start out with energy. So it's kind of a chilly day, and you've probably turned your heat on. And so think about where the energy is coming from. If you've got an electric furnace, they're generating that electrical power somewhere. If you've got a gas furnace, you're getting gas from somewhere. So we're going to start out by looking at energy resources. So let's jump into chapter 13, shall we? Here we go. So, squeezing power from a stone. It's hard to believe, to think that energy actually comes from rocks, but in fact, that's where they come from. The first part here, the introduction, talks about kind of what energy is and what a resource is. Of course, a resource is something that you are holding or finding and using, is a resource. Energy defined physically is simply the capacity to do work or to change a physical or biological system. So, for example, you are using energy right now, aren't you? You're using biological energy. You've eaten probably supper, or if you're watching this in the morning, you probably just finished breakfast. So either way, you've just eaten some food, and that food is being turned into biological energy in the form of what we call calories. And calorie is a measure of work, or a measure of how much energy there is in food. Uh, so we are machines, just like a car. We need energy. If we don't have energy, of course, we're going to run out of gas, as it were. But your book begins to look at then resources of energy on the earth. And basically, again, we're going back to middle school now, right? There's two kinds of energy. There's non-renewable energy and renewable energy. Obviously, non-renewable energy is energy that we take from the earth and we're never going to get it back. So coal and a lot of what we call fossil fuels, and of course we call them fossil fuels because they come from the stored energy in them comes from organisms that lived a long time ago. So coal is actually the leftover carbon from a forest or from animals, some sort of living organism that died a long time ago. That animal, then all of its molecules basically get frittered away, except for the carbon that gets stored, gets compressed as it, is rocks and sediments piled on top of it, and then eventually we find it a few 100 million years later and dig it up and then reintroduce the carbon by burning it, and taking the carbon out and putting it back up in the atmosphere, which is why fossil fuels are so terrible. But that also includes natural gas. It includes heating oil. It includes gasoline for your car. It includes kerosene. All those sorts of things come from basically the same place. They just happen in different ways, and that's kind of what your book is going to talk about in more detail. Then, of course, renewable energy sources are ones that we get over and over and over again, and we'll get into those later in the chapter. But let's look at non-renewable sources of energy up to this point. And most of what we've done up to this point as human beings is we've used non-renewable energy sources. We've used coal, and we've been doing that for over 200 years. Natural gas, we've learned how to capture and use. Oil, we've been using for about the last 100 years and refining it into many different products, including plastic. Anything you've got that's plastic, the natural resources for plastic is oil. And then some of the renewable sources, such as hydropower and um, solar energy, things like that. This is an older book. So if this was a new book, I think the numbers would be a little bit different. I think that we would see much less coal, quite a bit more natural gas, and quite a bit more of the other renewables, such as solar, which is getting easier to use because it's cheaper, right? And so that's where that's coming from. But anyway, so let's jump into these sources that we're talking about. So let's think about where all these different sources come from. That's what your book is going to look at here. So again, energy directly from the sun in terms of solar energy. This could be photovoltaics, which is like solar cells, or it could be just heating up water in a tank and then having that water, having that energy, that heat in the water to radiate out into a space and heat that space. Energy from gravity. So any kind of thing flowing from top to bottom. So all the hydroelectric power from dams and that sort of thing is because water is moving downhill, right? It came uphill from the sun, so you could say like flowing of water is a combination of solar and gravity, right? Because the sun has to heat up the water, it has to evaporate, go up in the air, come down someplace higher, and then as it coming down the mountain, that's when we capture it and use it to generate energy. um, and then energy via photosynthesis. So again, this is living organisms that take the sun's energy and turn it into sugars using a chemical process. You probably saw this in middle school, right? Taking carbon dioxide, water, and the energy from light from the sun and turning it into oxygen molecules, sugar, and water. And we've talked about that a little bit too, because this is where all of our oxygen comes from. Oxygen is a byproduct of this process. um, we work in just the opposite way, don't we? We take then the oxygen, mix that with sugar, and produce carbon dioxide. So living organisms like animals basically are burning. There we can see how that works on this next on the next equation there. Energy then, of course, from fossil fuels. So, and we'll talk a little bit how that works, but energy from fossil fuels include oil, natural gas, coal. And again, we said oil, it can be used to become all kinds of things, kerosene, heating oil, alcohol, all kinds of stuff. So all those things then come from essentially the same source, but just in different combinations. Energy from chemical reactions. A car battery is a good example of a one of these reactions. Any kind of exothermic reaction where heat is generated is an example of that. And of course, fuel cells. We'll talk a little bit more about what those are. Hydrogen fuel cells, which is something that's possibly a renewable energy source. Energy from nuclear fission. And again, these are nuclear power plants. We're taking atoms and we're breaking them apart and using the energy, breaking them apart rather, and using the energy that's released to heat up water, and that water runs a generator and that produces electricity. So, we saw a lot of those years ago. We haven't built any new ones in a while. The disaster in Japan kind of shows us why. If something goes wrong with that process, the radiation involved is pretty bad. So even though it's a type of energy that could generate a lot of energy with a small amount of material, that material can still cause quite a bit of problems. Energy from the Earth's internal heat. Here we're talking about geothermal energy. If you live on a volcano, you could generate heat that way. There are some countries like Iceland that live in a geothermally active area, and so they can get a lot of heat They get almost all their heat, as a matter of fact, from geothermal energy. So anyway, how does all this work? So how does coal, oil, gas, how are all these things, how do these things work? Well, we call them hydrocarbons. And hydrocarbons simply means hydrogen and carbon, right? So there's CO2 right there. So these are essentially carbon atoms, carbon molecules, in combination. When you combine them with oxygen, you get a reaction and you get energy released. We talk about these different forms of hydrocarbons in terms of energy density. So how much energy can I get from, a certain amount of material? And there you see a chart looking at energy density. Starting at the top, we have things like natural gas and bottled gas, like LP gas, that you use in your in some of your grills, gas grills and stuff. So they would release the most amount of energy for the smallest amount of material. And then as we go down, we get less and less and less energy from more and more material until we get down to something called tar. And tar is basically a natural material. You've probably heard of the Brea tar pits in California. And it's kind of a natural form of this carbon, which has a lot of impurities, so it's not very efficient. So here's some, again, you don't have to memorize all these equations, but they're basically just kind of showing you, excuse me, for example, how these hydrocarbons work. So this one is, we're burning gasoline here, where we basically take the gasoline molecule, add oxygen to it. And that's essentially what you do when you set something on fire. As a chemist, in chemistry, when we get ready to heat something up or set something on fire, we don't say we're going to heat it up or set it on fire. We say we're going to oxidize it. We're going to add oxygen to it. And that oxygen then can cause combustion. And that's what happens in your car engine. We combust the molecules of gasoline. They react with the oxygen in the air, and they produce, as you can see, carbon dioxide and water. And of course, heat and light and vibration and noise and all kinds of stuff, whatever, like I said, if you're driving a car or a tractor or something, all kinds of different things come out of that reaction. So that's essentially what's happening. And that's, in a nutshell, why these kinds of energy sources are bad for the environment. And we've known this for quite a while. And now realizing that we really need to do something about it. You can see all the carbon dioxide that gets released in a gasoline reaction. This happens when you're burning wood in a camp stove, or a campfire, anything like that. Even you are oxidizing carbon molecules right now and releasing carbon dioxide. So you just breathing are part of the problem. But of course, there's easier ways to fix the problem than to get rid of all the people, like getting rid of cars and getting rid of factories and stuff that burn a lot of coal. So this is how it works, basically chemically. It comes from what we call source rocks. So these source rocks here, you can see kind of how this happens. The material gets collected from some sort of living organism source. That carbon gets crushed over time, more and more pressure, and then finally that becomes the source rock that can turn into all kinds of things. It can turn into coal, it can turn into oil, it can turn into natural gas, depending on the geology of the area and the amount of pressure, the amount of time. So it all comes from this source rock. And when we dig up coal, if you've seen big seams of coal out in eastern Kentucky, that is in fact the source rock. That is where that material ended up several hundred million years ago. And so go ahead and read this chapter. I'm not going to go into a whole bunch of it, but they talk about different kinds of reserves, which is all very interesting. We talk about conventional reserves, which are kind of what we read about and hear about. So, for example, oil, conventional reserves in oil, we find a lot in the Middle East. We find some in the United States, like places like Texas and Alaska and offshore of Louisiana. Conventional resources for things like coal. I mean, we've seen those in Eastern Kentucky and West Virginia and places like that. So these are all conventional reserves. And again, go through this chapter. It's a little bit more detailed than you really need to worry about, but definitely go through it and read it and kind of get a feel for what they're talking about here. But I'm not going to hold you to traps and seals and all kinds of that sort of thing unless you want to become a geologist. And if you do want to become a geologist, most of them are hired by the oil companies. So this would be a good thing to know as a geologist because they hire all the geologists just to find oil. And this is what you'd study in college. But anyway, so we get to this oil by drilling. Once we've drilled and we've got what we call crude oil, we take the crude oil and we begin to refine it. We refine it by heating it up and separating the different particles, and that's where we get the different things like gasoline and kerosene and heating oil. It all comes from the same place. Very interesting history of oil, where it's discovered in New York and Pennsylvania, and then we get the gasoline engine. Right, we use kerosene for quite a while, and then we refine it to even more like gasoline, and then we find a bunch in Texas, and finally Alaska, and then the Middle East. And now we have lots of gasoline, and it's cheap. I mean, that's why, as a society, that's why we turned to fossil fuels. They were cheap. We just dug them out of the ground. Turning sunlight into electricity was difficult. I mean, it takes technology. Thankfully, we live in a world where technology kind of gets better and better and better, and the cost of things that we, use to do that get cheaper and cheaper. And so now, solar energy is a lot cheaper than it used to be, and it is definitely the energy of the future. So it's unfortunate that we have to have these fights, and I guess it happens in any society, where you're changing from one thing that's already been established. There's a whole system of mining and drilling and refining and cars that all run with gasoline, and now we're talking about changing that all over to something else. It's expensive and it's confusing and it's frustrating, and then 20 years later, everybody's wondering why we didn't do it earlier. So that's kind of where we're at there. They go into unconventional hydrocarbon reserves. This is where we get into some of the things that are happening now, like fracking. So again, you've heard of probably that word fracking. And again, this is all got to do with technology, learning how to get more energy out of things like the tar sands. Whereas before you would have just ignored it because it would have taken more energy to get gasoline out of it than it would have been the gasoline that you got. So now the technology has changed a little bit, and that's why I said that chart at the beginning would look a lot different, because using fracking, we can get a lot more of this natural gas out. Here you can see oil reserves and this stuff called a shale gas. So shale gas was ignored years ago because it was too hard to get. In other words, they wanted gas in big reserves, big chambers of gas where you could drill into that chamber and suck out the gas. But shale gas was in these little bitty chambers, and it was hard to get to because you spend a lot of money to drill and just get a little bit of gas out, and you have to drill another hole. By fracking, what you do is you break all those chambers up, and so all that material then kind of comes from one area. You kind of force it out with some sort of liquid, and that's where this hydrofracking or just fracking comes from. It's very controversial because, well, there's a lot of pollution involved. That's not good. It kind of destroys drinking water. Like if you live near some company doing fracking and you get your water from a well, you can get on YouTube right now and watch people set their water on fire. the water coming out of their that gas has gotten into their well water, right? And when they turn on their kitchen faucet, they can literally set their kitchen faucet on fire with a match because there's so much gas coming out. So it's kind of a bad thing if we don't do it properly, and we've not been doing it properly. So it's kind of a bit of a problem. So it's going to last for a while, but again, it's a non-renewable resource. So once we do all the fracking and we get all that out of there, I mean, then we're done. I mean, we have to start moving towards something else, and that's what we're going to argue about here at the end of the chapter. So here we look at oil shale, and again, this is the lowest grade of a natural resource. It's not coal. It's not used very much. And so here's a whole section here on the fracking. So please read that. It's very interesting because it is a political issue. I mean, it is being fussed about in terms of, yeah, we're doing it. Yeah, we're getting more cheap energy. But again, it's not going to last. And is it a good idea to ruin groundwater just to get a little bit of gas out? So um, do read that article. It's very interesting. And if you're interested in it some more, there's plenty of articles that you could do a science inquiry paper on, which would be great. So yeah, again, this kind of shows you how fracking works, and it's very interesting. Definitely look at it up. Coal we talk about here, where this is something we see a lot here in Kentucky, and of course, coal is difficult to get out of the ground. We dug mines for a long time, and now, of course, with heavy machinery, you don't have to dig a mine anymore. You just take the top of a mountain off to get to the coal seam. So this is what's called mountaintop removal. They literally go out in the mountains and literally tear the top of a mountain off. And so there's been a lot of controversy, as you can imagine, over that to get to the coal. It's very expensive. And so once this cheaper gas, this natural gas, which is cheaper, comes on the market, now there's less demand for coal. And so a lot of these coal companies have gone out of business. And it's very unlikely that coal is going to come back. We'll continue to use coal because a lot of the infrastructure is set up for it, like LG&E, who uses coal. Your lights that are on in your house right now is probably coming from burning coal. But they are not building any more coal plants. They won't build anymore, and they're converting a lot of their coal plants over to natural gas. So that's definitely going to go away. And of course, these companies are smart. They're already looking at and building solar farms. They're already building wind farms. So I mean, I know we argue about it politically, but these companies, they're there to make money, and they know that this stuff is not going to last forever, and they know it takes time, and they want to be, there on time, and so they're already doing it. I mean, it's kind of funny that we're still fussing about it, and they're really moving on, and it will happen. It will happen pretty quickly when it does. That things will kind of start to change over. But anyway, yeah, we talked quite a bit about coal, but really, coal is just about gone. I mean, there's just not much. There's just between the cost of getting it out of the ground, the cost of moving it, and then the environmental cost of using it, and so it's really I would say definitely in your lifetime you're going to see coal pretty much go away, at least in this country and most industrialized countries. It may last in a few other of the lesser developed countries, but it's pretty much gone. But you can see how it's done. It's pretty interesting stuff. Again, there's also fires. These things, these mines will, we've all seen mine disasters where people have killed in mines, but also where the coal, this big coal mine will catch on fire, and there's no way to put the fire out. I mean, this is coal, and it's just going to burn and burn and burn. And some of these fires have been burning for, it says here, for 50 years. So if you can imagine a fire burning for 50 years, and they say it probably will continue to burn for another, couple hundred years, because there's just no way to put it out. As long as it's got oxygen, it's going to continue to burn. Then your book looks at nuclear power. So nuclear power, then, of course, we know that atoms, big atoms, can be broken apart. Atoms like uranium is a big atom that you can take, and as you break it apart, you're releasing energy. And you can make a nuclear bomb out of that if you do it all at once, or if you do it slowly. You can heat up water, and that heated up water will create steam, and that steam will run a generator that generates electricity. So that's where we get our electric power from a nuclear power plant. They're very inefficient, but they do generate a lot of energy from a very small amount of material. So it doesn't take much uranium to generate quite a bit of power. But of course, it is radioactive. And so if there's an accident, and we've seen quite a few of them over time, if there is an accident, um, it can be disastrous for the people that live in the area and for um, the environment. Because as we've seen in Japan, the accident that happened there, entire cities are now just completely gone. People just had to leave. The worst one we probably saw was Chernobyl in Russia, and today that is a tourist trap, a tourist destination where they can go in. You can go in for a few hours, and literally people had food sitting on the table when they were told to leave. So it's pretty amazing. Not to mention the fact that the plants are contaminated, animals are contaminated. So it's kind of a big experiment to see just what would happen. Chernobyl happened several decades ago, so they're really studying it to see what happens after one of these disasters. It's not quite as bad as we feared, but at the same time, no one is really crazy about going and living there. Uh, so anyway, so these were a big deal back in the 70s. We were building lots of nuclear power plants, and then after some of these accidents, that stopped pretty quick. So it's very unlikely that nuclear power is going to ever get big again, unless again there's some sort of big change in the technology. There's an idea of something called cold fusion, and if cold fusion ever happened, that would be a pretty cool thing. But the physics aren't there yet, and so maybe your grandkids will discover something really cool like that. But until then, nuclear power is probably, and again, it's a non-renewable resource. You're using material from the earth. It has to be mined. It has to be processed, and so it's just not a renewable thing. Then when we talk about renewable sources, we talk about geothermal, and again, geothermal kind of depends on where you live. Uh, New Zealand, there you can see in the picture, uses geothermal energy, as well as, like I said, Iceland. I think the entire island of Iceland is heated by geothermal energy. So they have zero energy bills, even though they live in a very cold climate. They get free heat. That's probably what this is here. I'm not sure. Could very well be. Oh, that's still New Zealand. Biofuels. Bio, of course, meaning life, and these fuels come by taking plants, certain kind of plants, and creating alcohol. We've been doing that for hundreds of years, but we've been drinking the alcohol by using corn and wheat and things like that. But you could take that same alcohol, we call it ethanol now, and you could put it with your gasoline. So a lot of times when you fill up a car with gasoline, you're getting about 90% gasoline, but you're also getting about 10%, sometimes as much as 20% corn. So these are biofuels, and there's lots of things that we could use for that. And the technology, again, is growing on that. And so that's definitely a renewable resource. You can grow more and more plants. Then, of course, hydroelectric and wind power. So hydroelectric, if you've got a big dam nearby. This was done back in the 30s and 40s with Tennessee Valley Authority. They built dams on the rivers in Tennessee and Kentucky and West Virginia, places like that, and got energy and got power to folks who lived out in the rural areas. Wind power, we've seen a lot of places, things happening there. If you've ever driven up north through Indiana, headed up towards Chicago, you'll see a big wind farm up there that was put together by Purdue University, and they generate a lot of energy from that. So that's definitely possible. Again, you got to have the wind. There's tidal power, where you can use the tide as the tide comes in and out. You can generate energy using tide and using waves. So there's all kinds of ways. Oh, excuse me. That you can generate renewable energy. And of course, solar is the one we think about probably most often. And again, solar can happen in a couple ways. You can have what's called solar voltaic, where these are like solar cells, where you put these solar cells and they face the sun, and the sun, the cells turn that solar energy into electricity. For a long time, they were sort of a toy because took a lot of surface area to generate a small amount of electricity. But now the technology is getting better and better. And so these solar cells are getting cheaper and cheaper and smaller and smaller. And so now you can generate quite a bit of energy from a small bank of solar panels. And so there are solar farms. There are several. There's one in Shelby County, a big one that you pass on the highway. So there are several of these solar farms. They're generating solar energy. The technology is getting kind of amazing because you can go buy windows for your house, and those windows are a clear solar cell, and you can literally plug things into your windows. It's getting even crazier in that there are paints. You could even, at some time in the future, be able to paint your house with a couple different kinds of paint, and those two paints together create like a solar cell, and your entire house might be generating electricity. So the technology is really cool there. And of course, the sun's not going away, at least not for another 4.5, maybe 5 billion years. So we're going to have that energy almost constantly. The big question now with solar cells and solar energy is the batteries. We need a way of storing that energy when it's a cloudy day or when it's raining outside. And so we're working on batteries, and that's the big thing with like solar cars and things like that. Fuel cells are fairly new. It's a chemical reaction between hydrogen and oxygen. And it creates electrical energy, and so you can have a solar. These were used quite a bit in the space program using hydrogen fuel cells because the byproduct, you don't need. I mean, you can bring your own oxygen with you, and then the byproduct is water. I mean, the waste is water, so they're very good on the environment. But they could very well easily become something that we would see in the future. So the last part here kind of looks at the environmental cost and the economic cost of energy. And this is a big political deal, isn't it? We've all seen and witnessed the discussion and the argument about where we're going to get our energy in the future. And so it takes an infrastructure. You can't just stop doing one thing and start doing another one. It takes time. And so this is where the argument is happening. This is where the people are fighting about how that's all going to happen, and your book looks at that from a general standpoint. There's your big picture that you need to look at and put in your notes. And then this is kind of interesting, asking about other fossil fuels replacing oil. Highly unlikely. Things are going to have to change. Any kind of fossil fuel is going to be bad for the environment. And we're already seeing that when we change the climate, we change the environment. And again, we'll talk about this at the very end of the book in a lot of detail. But when we change the environment, change the climate, it's going to cost us more with all the effects of that than it would to change the kind of energy we're using. So it's important to think about all the factors before making a political decision about what we're going to do there. So let's see. There's Deepwater Horizon disaster. We know all about that, and the oil spills and what that does to the environment. So that was a very interesting thing. It happened when the book was printed. So there's other disasters that have happened since then. Your review questions are here at the bottom of page 543. And again, this would be a very good subject if you're interested in it to do a science inquiry paper. And I look forward to seeing those when they come in. I'll see you next time.